everyone. Please بس في حدا to confirm إنه you can hear me clearly.
Yep.
Okay. Hello everyone. My name is Mustafa Najm. I'm the founder of Hogwarts of Engineers. Thank you أول شيء for joining us today بهذا الويبينار. Let me بس start with a very brief briefing about Hogwarts. We are an online community. Our main goal is to help engineers excel in their fields. ما راح احكي كثير عن Hogwarts. You can check out our social media and the website. We are creating this series of webinars لأنه هلا كل العالم عم بتروح على الأونلاين learning, so we are trying to participate بهذا الفيلد. We are trying to bring into the community the best our experienced seniors بهول الفيلدز. اليوم we are joined with a special engineer Alaa Salam. Engineer Alaa Salam is mainly a biomedical engineer. هلا إذا بدي أحكي كتير عن آلاء ما راح ياخذ الويبينار راح ياخذ كله، بس عم نحكي عن آلاء شو بتشتغل. هلا هي راح تعطيكم more details أكتر. Mainly آلاء راح تحكينا عن how they are fighting COVID-19 using technology. Alaa is a part of the Lebanon Response Team. إذا سامعين فيه عم يشتغلوا trying to back up the medical staffs بلبنان ليقدروا يواجهوا كورونا ب using technology. Alaa is a managing member of Lamba Labs, if you are familiar with Lamba Labs. تشوفوها كتير بكل الايفنتس اللي لها علاقه بالتكنولوجيا بتشوفوها بلبنان. راح اترك المايك هلا لآلاء تشرح لكم اكثر هي شو بتعمل وشو راح تحكي لنا اليوم.
Okay, thank you so much, Mustafa. Overdoing it a little bit, but yes, you will see me in every tech event because I'm really passionate about technology and my main specialty is in the medical field. So whenever you have these two fields mushed together, you're gonna find me there always at the epicenter. Okay, so a little bit of a background عني. I'm a biomedical engineer. I've been working as a senior field service engineer for the past 10 years, upcoming on to 11 years. The more I say it, the more I feel older. I've been part of Lamba Labs since 2016, which is a local makerspace. Basically, what we do is we have all these geeks, weirdos, and engineers, programmers, a lot of people who work with their hands. We get together and we try to do projects together. We used to do something called build nights every Wednesdays. Hella COVID-19, we kind of like shut it down, but hopefully we will restart that soon, where we get together, try to do projects together. For now, what we're doing is basically we're trying to do webinars, online, kind of like workshops, hands-on workshops. عادة احنا كنا نعملهم, but these days it's not feasible with the COVID-19 epidemic. And since we are working as makers as the field, and as my specialty is in the medical service field, when the COVID-19 pandemic hit us, this is where we saw an opportunity to help the medical field with whatever shortages they were experiencing. And we started a small group called Lebanon Response Team, which is basically specified to which started actually just to target the COVID-19 pandemic and try to help or support the healthcare sector with whatever they need in production of PPE. We also produced the first open source non-contact thermometer in Lebanon, and the actual precision تبعها. Actually, Mustafa, if we can move to the tab تبع non-contact thermometer, they can see a little bit about it. This non-contact thermometer is actually the first non-contact thermometer in Lebanon that it's open source, that the code is available there, the design files are available there, and it has been benchmarked against 10 medical grade thermometers in the field, including the B Brown one, which is the #1 in the field. And we got a precision that matches that of B Brown, which was our greatest accomplishment. We would try to move that into production. Problem is, with the economic meltdown, we were not able to secure enough funds to do that, but hopefully we will try to do it soon. We also tried to produce PPE, which is basically face shields, face masks, and other supporting accessories in order for medical staff to use them, be it in hospitals, medical centers, or even the public. We distributed also face shields to public drivers and buses and the communities that are actually always in contact with people like supermarkets, pharmacies, and teachers who have those of special needs where they need to be present with the students in order for the session to work out. So basically what we did is leveraged maker skills, which includes 3D printing. So what you see in front of you is an example of how we use a 3D printer to kind of like design and improvise a headband for the face shield. The face shield right now, it's not available in front of me, but usually we cut it with a laser printer. And what allowed us to do this is basically the design files were shared with the maker community online. And we directly became part of a group called Open Source Medical Supplies, OSMS. It's an international chapter where all makers just joined in and they started producing solutions to help medical staff in order to fight or even manage COVID-19. One of the most popular design was the one from Prusa, which is a maker of 3D printers. And this is because the design includes two partitions for the headbands where your air passes through there, right? And it allows for the viewer not to have a foggy screen so they can see everything. And the headband on itself, so if you put it over here, you can feel comfortable when it's placed on your forehead. And at the same time, the headband and the kind of front cover are detachable. So if you need to change it, you don't have to throw it away and then get a new one. You just take out the front and you put another shield on front of it. And these designs, they were not tested for sterilization outside. So us as Lebanon Response Team, what we did is we did a something called a bacteriology test, where we got us some live bacteria and we swabbed them on different types of plastic that are used in 3D printing. And we placed them into sterilizers and we sterilized them either in cold sterilization or in hot sterilization just to see which techniques work out. And we figured out that the EO sterilizer, ethylene oxide, is the best option we had. The best sterilization happened and the كادر ضلوا نفس الفورمات تبعه. Otherwise, we had some deformities because we know that it's very susceptible to heat, and at around 50 degrees, the plastic does not melt, but it does deform. So if you leave it in the sun for long periods of time, or if you even leave it in your car for long periods of time, that kind of band just melts or deforms. And we also raised this bacteriology test and we gave them the results to the OSMS chapter. So now they have kind of like a topology on how to sterilize and properly disinfect these head masks. Another design that was popular for the makers to help with the medical staff is something called the ear guard. So basically what it does is holds a face mask better. And what we did is we kind of like went for a design that's a little bit more malleable and Okay, so sorry. So you can just see it. So what happens is that it's a bit stretchy, and this allows us to wear the face mask onto our heads without actually defecting our ears, or even the ones who wear veils like myself can wear it on their face without suffering from the necessity of taking out the veil, wearing the face mask, and putting on the veil. And the medical staff that have long shifts, for example, we're talking 12 hours, 14 hours, 24 hours, 48 hours, which is happening nowadays. This is helping, this design is helping these medical staff to relieve the pressure off their ears. So this has become a very popular design. And we actually reached production of 7,000 pieces and distributed in every single Lebanese hospital around Riyadh. So this is this was a blessing in disguise. And this was designed by a 12-year-old. So you can now see how technology has changed the face of uh, the medical field just by because we had this pandemic that hit us, and the local health sector, even abroad, was not able to kind of like face it on their own. And the speed by which it spread was devastating, it was horrible, it was scary. So they tried to reach out to anyone who would help out. And this is where the maker community stepped up and they said, we have all these tools, we cannot do anything else, so why not dedicate it to the healthcare sector and try to find solutions? And this is what happened. They started coming out with solutions. Everyone started thinking of something. Why don't we need this? Why don't we need that? And we had this kind of like interface between us and the medical staff because of us, biomedical engineers, where we came and we said, okay, we have ties to the maker community, we have ties to the healthcare sector. Why not join them together and try to have a conversation going and see what they want as doctors or physicians or nurses, what kind of problems they're facing that we can find solutions to. And this is where something called the Aerosol Intubation Box. It looks like an acrylic box, looks like a govaz. If you've ever been in an ICN or you've seen movies where they have babies in these small containers. So it resembles that, but what happens is that we have these holes where the doctors can go in and they can manage an intubating case for a patient that is COVID-19 positive. And at the same time, they can protect themselves further from any splash or anything while they're intubating the patient. Uh, this has been a very successful and a very high in demand design. And in Lebanon, our design was good because we modified the design in order for the makers to have a kind of like single piece entity being manufactured. And we reduced the production time on each aerosol box. So the international community took our design, published it, and now we're working on that design on an international level. So this is kind of like a small insight in what kind of PPE and uh, what kind of like items that we've been using on a maker side. We also had people who work in sewing machines, and we typically consider them as makers because they make something. So they designed a non-permeable gown, which we actually makeshifted from sterilization paper. And what happened here was us biomedical engineers, we tried a lot of materials, and then someone suggested, okay, why not use the halyard sterilization paper because it's thick, it can be made as a material of a cloth. But then I said, well, crepe sterilization paper also has a very good uh, rate of water phobia. There is no water, you can't have anything seep in, but at the same time, it's breathable and it's way cheaper than the halyard option. And so we tried to sew it up, and it worked. We take about four 120 by 120 sheets of sterilization paper to make two gowns. And right now, what we're doing is that basically. So we're using sterilization paper to make gowns, and they can be washed and reused. so we're not wasting any resources, and we're using what we have because the gowns that were released into the market are either very expensive, especially with the conversion rate of the USD dollar in Lebanon, or it's not accessible as an option provided here, or it's permeable. So basically, it gets wet. And this is something that you don't want when you're working in a COVID positive floor for anything to seep in, because that's how it gets transferred. And yeah, so this is basically some of the options that we were working with as Lebanon Response Team on the ground. And so far, it's been very positive. The doctors are becoming more acceptable that these kind of options, makeshift options that are even made at home, can hold their ground on the medical field. And they've been using them in OR rooms, they've been using them in ICU rooms, and no complaints. And actually, the design of the headband on the face shield is the #1 design in all the hospitals in Lebanon, because they tried a lot of face shields and they spent a lot of money. And then they said, well, there's this little group giving them for free. Let's order some samples and see what happens. One day later, can we have 100, 150? Let's see how much can we get out of you. So yeah, it's been positive. We've had a lot of success on the field, and we're happy to announce that this is the kind of change we did in the healthcare sector. Another thing that we did, and I'm guessing all makers went through the stage, is basically in November and December, there was this shortage of ventilators worldwide. And this is where the maker community said, aha, our chance has risen for us to design an open source ventilator. And a lot of designs were suggested onto the market. Some of them made it, some of them didn't. But one of the designs that we have been working on as Lebanon Response Team is still in development, because we still need to prove the concept, and we can showcase the link if you
Alaa,
don't mind.
just a minute.
Mustafa? Yes.
Since you were talking about PPE,
Yeah.
بدنا عندنا سؤال صغير، لأنه كتير في ناس عم تشتغل على هذا الموضوع، وكتير ناس جربوا يشتغلوا ب 3D printing تحديدا،
Yeah.
اللي هو موضوع 3D printed face masks. So مرق عليك كتير face masks 3D printed، في شي منهم complete garbage that should not be used، وفي منهم So what are your points أو شو ملاحظاتك على هذا الموضوع؟ شو لازم العالم to take into consideration when they are making their own mask؟ لأنه هلا أغلب الناس عم يروحوا على 3D printing بس ما عم يعرفوا شو بدهم يعملوا. So what are your
Okay, so we tried a lot of designs on the market. The design اللي كتير لاحظنا فيه انه فيها اكتر شيء success انه ما تتعوج او ما تنكسر بسرعة هي البروجا design. You can try to modify the width, بس the thicker it is كل ما بتضاين، بس كمان ما تستهمكوها كتير، لانه نحن لقينا انه a 1 centimeter to a 15 millimeter, so 10 to 15 millimeter thickness is more than enough for it to hold its place and not actually break off. Actually, if you just 1 second. Okay, so these are broken materials. You can see that sometimes the quality of the PLA is not enough. And what we do, or basically my job, one of my main jobs in Lebanon Response Team, is to do some sort of quality control on every single item we release into the market. So كل ear guard, كل face shield بيمرق على هيدول الإيدتين قبل ما ينزل على السوق. لأنه what I do is I stress test it and I make sure that it can hold before actually giving it to someone in the medical field. لأنه تصور مثلا حدا يجي يحط الفيس شيلد and then right? And بيكون لابس كل شيء ومن top to bottom, and then he has to take off everything so that he can put on another face shield. It's not viable. So I would say try to make it a bit thick. So even though it uses a little bit more plastic, it's okay. but you'll be using it on a longer run. So you're saving yourself time, you're saving yourself money. Another thing that we notice is that the spacing of the notches, all right, are typically good on a Prusa design, and it's more than enough to hold the actual face shield cover in a contour base so that your breath does not reach the main face and it goes and it gets released onto the sides, right? And make sure that the length of the front cover, right, is reaching your chin. مش بس يكون موجود لفوق. لأنه yes, you may be wearing a face mask with it, but it's always good to have an extra length to prevent any contaminated air in your surrounding coming in. Now, usually if you're not working with COVID positive cases up close, it's okay. But it's always good to have a face shield that covers your entire face and you're comfortable with it. And when you're breathing, all the breath is going onto the sides or up than onto the actual front of the face shield. Another thing that we notice is that the headband, okay, try to choose a type of elastic اللي بيستعملوهم بالمغيطات تبعول stretch pants لأنه بيضاينوا منيح and they're also sterilizable وهذا الشيء كتير مهم. So at home, your options of sterilizing your face shield is typically mixing some alcohol بيكون 70% pure usually. You mix it 1 part alcohol, 1 part water, and then you just spray it onto the actual face shield so that it gets sterilized. If you have hand sanitizing gel that is a little bit liquidy, you can make your own solution. But we usually try to recommend alcohol. It's much better to sterilize with alcohol than with face gel. And with face gel بيعمل مثل كمخة. And another thing is that the design should have the rubber stitched onto it, not on outside. لأنه جربنا نحن نعمل واحد من الديزاينز يكون on the outside terminal, and sometimes when you wear it, it just goes off. So these are kind of like pro tips when you're trying to design your face shield at home. And another thing is that choice of material is very important. We noticed that PLA is the best plastic to use. بيضاين منيح, it's cheap enough to buy. We tried TPE, wasn't good enough. We tried ABS, which surprisingly enough ما كان يحمل stress مثل ال PLA. So we ditched that, even though it holds better temperature لأنه بيتحمل لحد 100 درجة. ABS ما بيتحمل ضغط أكتر. So if you have ABS and you want to design a headband, it's always good to double the width سماكة ال actual plastic, not the width. عم نحكي من العرض, عم نحكي من السماكة. So إذا بدكم ال height or the axis تبعكم, try to make it thicker so that it can hold the tensile force when you're trying to wear it and take it off your face on regular intervals, especially if you're working in a supermarket or a pharmacy or even in a clinic. Always have the type of material well selected. For the front cover, في عنا different kind of sheets بالمكاتب. أكتر شيء عم نكون عم نستعمل بالمكتبات. Try to make sure that you can see clearly قبل ما تشتروا ال actual material. So anything that's foggy, أي شيء في تلميعة, يعني try to sit تحت الشمس, try to see different lighting scenarios. قد إيه عم بيكون في نسبة اللمعان عليها. Try to bend it, لأنه sometimes if you bend it enough بيبلش بيطلع عليها stretch marks and you have these little breaks بقلبها. So try to make sure that you can see everything, and even though you are moving around and if you're taking it off and on and you're working with it, لأنه when you're working, you're not going to sit straight and try to move like a robot. You're going to be dynamic. Try to test it out. Always test it out on the field before you actually reach a final design.
Okay, Alaa, I have last question. كرمال ال PPE. انا هذا الشيء اول شيء هذا الشيء انا عملته فور فن. اوكي سو دونت جادج مي. بس في كتير ناس عم يعملوا هيك شيء to use it
Yeah.
in real life. So what do you think about this? So what are your opinion? شو نصايحك لهول الناس؟
Not at all. Actually, go for it. Design with everything you think you might need. Some people are designing things that are opening doors. So a door holder, and you just open doors. It may sound ridiculous, but you have no idea how helpful it is in maintaining social distancing. لأنه everything that's being touched by others, you need to touch back. And the supply of gloves, especially in Lebanon, is on a really low stock. So if you're wearing gloves every time you go in and you have to dump them out, because never, ever, ever wear gloves and keep them on for more than like 4 or 5 hours. Everything you touch sticks to your gloves. Try to keep your gloves away from your hands as well. So if you're using tools to open things in different means, even if you are installing an Arduino circuit onto your faucet so that you and the rest of the family don't have to touch the same faucet at the same time, go for it. Go crazy. نحن بالhospital, what we did بمخيم عين الحلوة. So this is one of the hospitals I work with. We had a problem with the sterilization dispensers for soap and sanitizers بقلب hospitals. They kept breaking off. I went back to the community. I said, well, ما عندنا حل بالmarket. We cannot import something else. What can we design? 3-4 iterations later, we have a good design, and we put it, and it's adjustable لأنه بتقدر تنحط فيها كذا نوع container. We just adjust the diameter and the length, and the pumping mechanism عليناها زيادة so that people can use their elbows instead of hands. So now social distancing is better. And the people who are coming into the hospital, be it the medical staff, nurses, doctors, patients, they're more comfortable using a design that we 3D printed and did on the field than the actual one that we paid lots of money to get and it broke off. So don't say that this might not be used in the field. This may not never see something to happen. تقبل الدكاترة وتقبل الميديكال ستاف ليجربوا الأشياء is very high, especially now. Okay? I have a physician اسمه دكتور مصطفى قصب. He is the head of ICN in قصب hospital. هيدا الزلمة and is a real maker. This guy is a maker. And he has 100% tolerance. You give him something, he'll try it, no matter what. أول شيء we test it on analyzers and we try to test it as much as possible on the field without interaction with patients. But if you need to break the barrier with patients, this is your guy. If you have something and you want to test out, he said, bring it on. He'll make time. مرة قاعد معي بس عشان نجرب الجوفاز عملنا handles لألون لأنه الهاندلز اللي عم بيجوا من الشركة ضيقوا. So he said, can we do something about it? And I said, well, we have 3D printers, but I'm not sure if it would work. And he said, okay. جبنا له يمكن جرب معنا 19 ديزاين 19 تصور قديش في عندك tolerance. كان حكيم غيره قال لك خلص اول ديزاين ما ماشي ثاني ديزاين ما ماشي خلص ما بقى بدي. بس لما بيكون في عندك someone who's saying 19 and he's saying okay, let's try to improve it, let's try to design this, let's try to do that. لما بيعطيكم corrective actions and feedback, this is the best thing you can take from someone on the field. Always test everything you need on the field. And doctors also like something, which is free shit. So if you have something for free and you say, well, you can keep a version of it if you can afford it, they'll change their minds. We realized this مع non-contact thermometers, and we also had the group of engineers who were working on long distance كمان thermal imaging, and they offered it to a supermarket for free. If they didn't do that, they wouldn't have been able to see what kind of deficits it has. And when you're testing it in a controlled environment, that's the key word there, controlled. You know what's going on. If you're testing it in a lab, you have like 5-6 people testing it out with you. These people know how to interface with your items. But if you give it to a user who has never used this before, they are bound to do something that will go against the grid of this, right? So you always anticipate that the user will try to use it in any way possible that you don't think about it. One thing that the non-contact thermometer that works on a distance, the design engineers didn't take into consideration is that people don't wait. When they go into the supermarket, they're used to spend what, 1-2 seconds in order to cross a door. If you're asking them to spend more than 5 to 7 seconds in crossing a door, they will go to another supermarket. They don't mind. People don't like to wait. So think about this. Think about everything. Take feedback. If it's negative, if it's positive, just take it. Work with it and try to iterate your design so that it can match the needs of the people who are using it.
Okay, cool. Um, let's get into the ventilator.
Oh yeah.
I'm excited for the ventilator صراحة. بدي اسمع الابديتس لأنه ستيل بعدني ما عرفت شو في عندكم ابديتس.
Oh yeah. Okay. So basically what we did was we saw all the designs of the open source ventilators going onto the market, and the main design that was very common is the portable ventilator that gives only oxygen without mix of air, and it's very limited in its options. And I have experience with these kind of ventilators or respirators بقلب ambulances. And a lot of designs were based on something called an ambu bag, which is a resuscitator bag. أكيد بتكونوا شايفينها بيشبه البالون. You push it, بيطلع air, and then you leave it, and then it inflates. It's basically used in CPR cases لما بيكون في عنا someone preparing a ventilator and you're just doing the first response. So we never spend more than 5 minutes على الامبو باج.
هيدا الشيء اللي صار العالم يعملوا منه ستارت ابس وطوشونا فيه.
Yes, and في عندك ال MIT ventilator وما بعرف شو.
Yeah.
But what they fail to tell you is that when you're trying to use it in a hospital environment, not even ICU, we put it in an ER. 48 hours later تجي بتشوف انه الشافت مكسور من هون.
Yes.
البالون خزق من هون.
Exactly.
Something happens. So imagine you're putting your patient onto that ventilator. Yeah, no. We tried a lot of designs. There was 1 or 2 designs, one from Czechia, and one was designed by, I think, a Colombian engineer that worked out actually pretty well, which was based on a Raspberry Pi. This one kind of like hit the mark with me because his design and our design are kind of like on parallel. So he used the right processor, he was using the right materials, he was using the right mixers, he put enough sensors. We usually use a flow sensor to monitor the flow لأنه نحن عنا بالventilation في عنا like 3 main parameters we try to look at: volume, pressure, and flow.
Can you please Alaa بس هيك تقوليها in simple terms how a ventilator works بس كرمال إذا عنا حدا من الأودينس حابب يعرف.
Okay, so بكل بساطة the ventilator is a machine that allows you to buy some time. Okay, we try to give a breath to the patient if they are not breathing or if their breath is irregular. Okay, that's why we have several modes of operation. But the basic job of a ventilator is basically to give a combination of air and oxygen to the patient. انتوا لما نحن نتنفس الهواء الطبيعي نتنفس هواء فيها 21% oxygen. بس لما يكون في عندك someone who has asthma or has something called acute response distress, which is ARDS. This ARDS does not allow the patient to actually inhale air مثل ما لازم. فبدكم تعطوه دفعة هواء، وهيدي دفعة الهواء لازم يكون فيها نسبة أكسجين أعلى من الهواء اللي موجود عندنا نحن طبيعيا. So what we do in the medical field is mix a medical air, which is 21% enriched in oxygen, with more oxygen. So بيتغير ال kind of like ratio of oxygen to any other gas بقلب air, and this kind of air نسحب منه الرطوبة لأنه we don't want any more fluids to go into the lungs. لأنه most patients that require a ventilator بيكون في عندهم some sort of fluids or precipitations بقلب lungs that you need to pull out. In order to do that, you need to give the alveoli more oxygen so that they can stay awake بيكونوا معك. This is what we call alveolar recruitment, which is basically we say hello alveoli خليكن معنا هعطيك أنا oxygen لتضلك واعي معي. The more you give them oxygen كل ما بيكونوا واعيين أكتر. بس you cannot give too much oxygen لأنه oxygen is a kind of medication. You will reach a level where that kind of oxygen is actually bad to the patient بدل ما يكون good. So there's always this kind of trade-off. How much oxygen I give the patient and at what time. So this is kind of the basic operation of a ventilator where you just put a mode of ventilation. كيف بدي أعطي الهواء شو بدي حدد بحدد دايما الفوليوم بحدد البريشر وبحدد الفلو. These are the main three. You put two والثالثة بتطلع معه. So I hope أنه كتير technical بقلب ventilator, but I really like working with ventilators if you haven't noticed.
Great. طيب, let's get into your prototype. شو اشتغلتوا? I can
Yeah.
share the links.
Okay. Do you mind sharing? I think if you can see the screen تبعك. Let me see if we can. Okay. Let's try to open the link of the. Okay, there we go. Okay. If you can scroll down to the section where it has the mechanical design or the. Okay, keep going. All right. You missed it. في وحدة بتكون الميكانيكال. There we go. Pneumatic diagram. Okay. Do you mind expanding that? All right. Yeah. Just the download manager. Can we take it off? Thank you very much. All right. So if you can see the pneumatic diagram in here, this is our patient. سميناه سعيد الحظ. And what we have is a design for a portable ventilator. So a portable ventilator basically recycles the air that's found outside, and you have an oxygen supply given with it, and it mixes it both together in order to give it to the patient, right? So what we have is, let's start with the ambient air. We have it going into an inlet filter and something called a water trap. The job of a water trap is basically to take out liquid water from the ambient air. لأنه بس يكون في عنا humid air ويفوت عنا على النفس نبلش نتضايق فيها. عشان هيك في عنا عالم بيكون حساسة ضد الرطوبة أو بس تفوت على محل فيه رطوبة عالية بتلاقوا أنه بلشوا يسعلوا أو يعانوا من التنفس. فنحن بنتأكد أنه كل هيدا المي انشال و it's pured and filtered from any sort of dust or any kind of material in the air. Then we compress it. An air compressor, what it basically does is تعطي دفعة الهواء at a specific pressure. Usually it is 4 bar لأنه this is the kind of pressure that we need on a ventilator so that it can give high pressure for the patient if we need it in one of the ventilation modes. It goes into a radiator or some form that actually traps even more air لأنه الهواء uncompressed بيكون فيها نسبة رطوبة معينة, and when you compress it or تضغطوها كمان بيصير في عنا نسبة رطوبة أعلى. So we need a double stage ليشيل المي منها. And then we put it into a tank. Why? Always save your air in tanks, because you never know when something fails on this end or on the inlet. You cannot تقطعوا النفس عن المريض هيك suddenly. You have to either open it to ambient air or you need to provide air for a specific period of time. So we put the compressed air in a tank, and we always try to take out whatever water that comes out of it in a water release. Now, this air passes through another filter called the Hepa filter. The Hepa filter's job is to try to take out basically the oil particulates اللي بيجوا من الكمبرسور، لأنه الكمبرسور بس يكون شغال كل شيء في عنا items that are يا مشحنة يا أما واصل لزيت يا أما working or even حتى small shards of metal اللي بيكونوا resulting just with the grinding of the actual motor, no more no less. بيكونوا particles that we can barely see. All of this needs to be taken out. We also need to filter the kind of air that's in the room, because if you're placing someone with COVID-19 in a room, in an enclosed room, الهواء اللي عم يطلع من ventilator back into the environment will have, or we don't want it to have all that viruses back into the environment. So we use a HEPA filter to filter it and keep it there. Our air then goes into something called a PSOL, or a proportional solenoid valve. Proportional solenoid valves, basically they work like كيف الموتور okay, I forgot the name of the motor. We usually control it. Okay, I can't remember the name of the motor.
The servo motor, you mean?
Servo, thank you very much. Yes. Okay, a servo motor. So you know, and you have to supply particular voltage for it to move at specific notches. A PSOL valve is like a servo motor, بس بيتحكم بقلب valve. So we move the motor or the actual piston بقلب الvalve تبعها at specific lengths so that it can open or close to control the amount of air coming in. This is for the PSOL air in. For PSOL oxygen in, it controls the level of oxygen. Now, when we have a control of air and control of oxygen, it specifies قديش عنا نسبة الأكسجين بقلب something called an accumulator tank. The accumulator tank, the difference بينه وبين the compressor tank is the compressor tank فيها only air يعني at 21%، ما في عنا extra oxygen. بينما the accumulator tank لأنه عم بيستوعب oxygen ونحن نتحكم فيه بالكنترول تبعنا. We control something called fraction of oxygen into the actual ventilator. نقدر نعلي the percentage of oxygen inside the air via the accumulator tank. And the air going to the patient is always coming from the accumulator tank at all times. The only time the patient breathes the air in the room or from another source is when a fault alarm is issued and we have something called safety valve opens. It's right over here, PSOL purge. What happens here is that if something shuts off on this end, we don't want them to breathe nothing. بيكون ما بدنا إياها تفضى. So we open that purge valve and it opens up so that it allows the air inside the room to come into the accumulator tank and be given to the patient directly. Okay? This is the worst case scenario where we identify that the patient or the ventilator is down. The alarm is issued. عندنا دايما visual alarm and بيكون في عندنا كمان written alarm, and you have also the noise alarm. The alarm levels are always rise when we have something of this nature happens. So until someone responds and takes the patient off the ventilator, the patient needs to breathe some sort of air. We allow him to breathe the air inside the room. Another thing we need to observe is the pressure inside the accumulator tank. This is how we know that we have some sort of loss of air or oxygen. We have sensors to tell us that, hey, you need to pay attention. We have a problem here. Hey, we need to have something over here. Because the sensors that we're sensing at the PSOL levels are the ones that identify how much percentage of oxygen we're using. This is a setup sensor. So we cannot rely on it to identify if the amount of air and oxygen are going into the accumulator tank properly. Another thing that we also need is an airflow sensor, which is identified as entity H. So the airflow sensor on this particular position will see if the flow of the oxygen-enriched air going into the patient's lung is set at the level that we specified. Because when you are putting the properties of the ventilator, one of the properties that you have to control will be the volume and the time and the flow, or the pressure and the time and the flow. And from those, you can calculate, if you're putting the volume, you will calculate the pressure. And if you're putting the pressure, you will calculate the volume. The constant factor is always the airflow, which has to have a constant rate so that the patient can keep on breathing. And we have extra pressurized air placed into the lungs so that we call it PEEP, which is positive and expiratory pressure. This is the kind of pressure that we leave in the lungs so that it stays inflated وما يصير في عنا something called decompressed lung, right? عشان يضل في عنا هواء دايما عم بيكون داخل وجاي، يعني تخيلوا حالكم عم تعبوا بالون، right? If you leave it without air شو بيصير فيها؟ بتطبق على بعضها. We don't want that. We want the air inside the balloon to be present so that it stays inflated and we can still push air into it without hitting somewhere or having any obstructions. We move on to the P-sol inhalation. P-sol inhalation, basically, it controls so when we are breathing, we inhale, we take in air, and then we exhale. We let it out. There are two parts of the breath cycle. When the inhalation phase is happening, you cannot exhale. And at the same time, when you're exhaling, you cannot inhale. When you have a ventilator working and a patient working, you need them to be synchronized. You can't have a patient inhaling بقلب exhalation cycle, and you cannot have them release that air in the inhalation cycle. So we need to control them. We control these cycles with the P-sol inhale and P-sol exhale valves. Okay, so when the P-sol inhale valve is shut off, you can only exhale, and it allows the patient to release everything in the lung. When the P-sol inhale is switched off and the P-sol exhale is switched on, you can only inhale. The O2 sensor K will observe if our percentage of oxygen that we set at level E is the same amount that is reaching the patient. Okay? Now, check valves L and the pressure sensor M will not interfere in the level of oxygen being measured on level K. So it's okay to have extra sensors or extra valves after it. That's why we put it over here on this end. Check valve L allows the air to go only one way and not go the other way. It's just control of pressure, no more, no less. And pressure M, pressure sensor M, هي اللي بناخد منها قديش عنا الانهيليشن pressure. Okay, Nirmeen is asking a question. لحظة, let me just see. Okay, it being what? Let's see. Nirmeen, do you mind specifying what you mean by it so that I can confirm if yes or no? Okay, until she answers, we can move on a little bit. So the pressure sensor M is the one that measures how much the ventilator controls it. Yes, it controls, typically speaking, in the assist control mode, the patient does not breathe on their own. So you are in full control of the breathing cycle. Other modes like synchronous intermittent mandatory ventilation or pressure support, you have the patient breathing and the ventilator is observing, and only when necessary it can give a pressure or a breath whenever the patient needs it. So the ventilator is kind of like a teacher trying to control a class. When they see the class is fully working, it only observes. But if it sees someone failing to do something in the cycle, it tries to compensate for it. Okay? Okay. Pressure M, pressure sensor M, it measures the pressure on the inhalation end. And this pressure is what we use in order to calculate if the tidal volume, so the volume of air going from the accumulator tank to the patient, is the right amount that we set. Okay? Now, I'm not going to go too much into the ventilator, but there are specific parameters that need to be monitored to make sure that the amount that we set as a user are being given to the patient properly. And we also have to monitor that whatever we are expecting from the patient to be breathing to also be right. Because sometimes you know that the set pressure مثلا for example البيب مثلا نحن بنحطها at 5 centimeter H2O, we're keeping the lungs open at 5 centimeter H2O. We notice from the pressure sensor that yes, it is there. Okay, which is pressure sensor O, by the way. Okay, if we have this reading is right, but we find that the pressure going with the patient is wrong. So we need to see what's going on. Do we have a leak in the breathing circuits that are connected to the patient? Do we have the patient's case is worsening? We need to increase the pressure. We need to decrease the pressure. So these are the kind of parameters and sensors. We always put more sensors into the circuit. We call them redundant sensors so that we can have full control and full view of the respiratory cycle, and we can compensate according to what the patient needs. Because the main objective of the ventilator between you and I, بمجرد ما تحط الفنتيليتر على المريض بدك تشيله عن المريض. It doesn't make sense to you, but ask any respiratory physician, what's your objective of using a ventilator? It's to wean the patient off the ventilator. It's always the target is to take the patient off the ventilator. That's why we try to give them the best type of ventilation cycle that they need in the shortest amount of time so that they don't develop further problems. Because the more you use something called mechanical ventilation, which is basically you're using a ventilator, the patient will start to develop these complications caused by mechanical ventilation. So they can have a collapsed lung, they can have barotrauma, volutrauma, excessive pressure, excessive volume. All of these can damage the lung more than it helps it. Regardless of the type of ventilator you're using, regardless of the mode of ventilation, sometimes your lung is just too tired to work with you, and you can't keep it on very long for long periods of time on a ventilator. That's why when we have patients that are months working on a ventilator, we say, okay, we need to find another solution. If we cannot get them off the ventilator, they will worsen, and we know that they will worsen. It's very rare that a patient who has been placed on a ventilator for months on end يطلع منها. But it's always the objective. Once you put a patient on a ventilator is to take them off the ventilator. Okay, so moving back into the pneumatic diagram, we reached pressure sensor M. So pressure sensor M to H, the flow sensor, this line, we call it the inhalation line. This is the line where the patient takes the breath or the ventilator gives the breath to the patient. Right. We gave the patient the breath. What do you do now? Just hold it in? No, you need to release it. So you need to put it back into the circuit, but pay attention. We have a closed circle in ventilation. Whatever you inhale is whatever you exhale, but whatever you exhale is whatever you inhale. So what do you use? We have to use another filter to make sure that the bacteria on the patient does not go back into the ventilator. And we have a very, very nasty bacteria known as Pseudomonas. Ask anyone who works in an ICU, what's the worst kind of bacteria you've ever dealt with? It won't be COVID-19. The bacteria أضرب شيء عنا نحن Pseudomonas. ليه؟ تحشر حالها بكل الزوايا. It's very tough to take out, and once it lodges in a small space, it takes forever to take it out. You can sterilize it, you can burn it. Sometimes it just stays there and it grows like crazy, and it moves on to the second patient. And this is our worst nightmare. Whatever one patient has, we do not want it to move to another patient. That's why we try to use as many filters as possible so that we can guarantee that the quality of air given to the patient is proper. The quality of air recirculated into the ventilator is also proper. Okay? So that's why we use an exhalation filter marked as R. And then we monitor something else. Just like we monitor the airflow على inhalation, we need to check it on the exhalation. Whatever you give in, you should receive back out, minus what the patient should have breathed. And this is what the ventilator calculates. So that's why we have VE, which is volume exhaled, and VI, volume inhaled, and VT, which is the total volume between volume inhaled and volume exhaled. The airflow sensor H بنستعملها كرمال نطلع VI، والايرفلو سنسور N نستعملها لنطلع VE. When we calculate VE and VH بيطلع معنا tidal volume that is measured onto the circuit. ونحن عنا set value. We compare these two values. We see, is there an acceptable margin of error? There's always some sort of leak happening somewhere. So your volume will be lost somewhere there. And also you also have the air inside the breathing circuit, which is also there. وحيضلوا هونيك. This is why we call it dead space volume. So the sum of these volumes, are they equal to the tidal volume that we placed? If no, this is where the ventilator sees, I might have a leak somewhere, and it raises the alarm, leakage. وانتوا فتشوا عليه. That's why it's always good to test your breathing circuit before you use it on a patient, because it's very hard to locate and compensate for a leakage when it's placed on a patient than when you're testing it in regular test mode. So that's why we also have على الventilator design تبعنا a stage where you test your ventilator every step of the way. All right, moving on. Pressure sensor O مثل ما قلنا هيدا البريشر sensor we usually use it to measure the PEEP pressure, which is a positive and expiratory pressure. In layman terms, it's the pressure that we need to stay inside the lungs so that the lungs can stay awake ويضلوا معنا ومصحصحين وعم بيتابعوا معنا انه نحن عم نقول لهم يلا فيقوا بدنا هيك ترجع تشتغل لحالك. It's like trying to rehabilitate these lungs. The more you give it PEEP, the better it is compensating with you, but ما فينا نطلع عن level معين. Always ال PEEP value تبعنا for depending على the size of the lung, it's between 5 and 7 centimeter H2O. And when we're done with all this pressure and all this volume, type where we want it to go, we want it to go back into the ambient air so that we can take this ambient air back into the ventilator and have our loop closed as a circle. So that's why we have an exhalation valve P, which is somewhat similar to PSOL and HAIR J, but instead of using a proportional sonoroid valve, you don't need it on an exhalation value. Why? Because you don't need to control how much the patient is exhaling. You always exhale at the same rate. بينما inhalation, it takes a lot of energy for you to suck everything out, but it's very easy for you to just let it go. That's why exhalation valves can be just regular valves. You open it, it releases everything, all is fine, all is good. And then back into the air. So I had to crash course the ventilator design today, which is something.
لا, that's
Okay.
great. That's great.
Okay. If anyone has any questions, please ask. You can also check the link for what we did concerning power-wise, what kind of sensors we selected.
Let's note that everything is open source and they can access it from the links.
Absolutely.
I will be sharing them
Absolutely.
in the chat.
We also try to choose حتى عندنا list of material on site. You have a choice between high end and low end. And even our low-end options are just the ones that you can be more affordable, but we made sure that these parts can hold for long periods of time. They may, for example, versus the high-end. A low-end may hold for 2-3 years before you need to change it. بينما a high-end, you can operate for 5-10 years without it breaking down. So we made sure that our delays are taken into account. Yes.
I want to mention that you're using Raspberry Pi. Some people might think إنه Raspberry Pi هيدا شيء educational. It's not that professional. By the way, أنا شفت مرقت مع كتير شركات one of the companies الماركت لهم هن بلبنان، الماركت لهم بريت لبنان، عندهم سيلز اخر سنه كان عندهم up to 1 مليون دولار سيلز. الكور للبرودكت تبعهم is a Raspberry Pi. It's not custom made, it's simply a Raspberry Pi just programmed with some GPIOs. بس هيدي هي. So Raspberry Pis are really reliable.
You need to make sure of what you're using. What we used على Raspberry Pi is the I2C bus because this is what we know that we can control and it has a very fast response. لأنه we cannot have any delays. And the delay, even though on the Raspberry Pi في delay, هيدا delay is acceptable. Actually, the Raspberry Pi has a better response than most microprocessors on Chinese ventilators. And this is medical grade and sometimes is CE marked and FDA approved. So never underestimate the potential of a Raspberry Pi. حتى there's something else. Do you know that the Raspberry Pi powers one of the best chemistry analyzers on the market?
Cool.
So this is, yes, ask an engineer. There is a design for a chemistry analyzer. There is also a design for, I think, for كمان an RNA sequencer بالDNA لما بيعملوا فحص بالDNA.
Yes.
في machine that is based on a Raspberry Pi and has more accurate results than Chinese models and Japanese models. So don't say that this has been made for that purpose. حتى you can also find, if you don't want to use a regular Raspberry Pi, في عندك alternatives of Raspberry Pis that are industry grade. Use those. Use those.
Yes, exactly. By the way, even Arduinos, I've used Arduinos before in an industrial controller to control the temperature in a confined space. ولازم كان الفرق not a half degree كان الدلتا تي. And Arduino كانت يعني more than enough لتعمل هيدا الجوب. So لا عن جد you can rely عليهم هول الكنترولرز.
هلا don't use an Arduino Uno. Let's be very يعني honest with ourselves and very open.
It wasn't an Uno. لا.
في versions that are industrial grade. Most probably the Portenta is a very good one. The MKR series is a very reliable one. حتى تحمل shock tolerance, which is amazing. The newer versions of the Wemos and the Node MCUs come in perfect to use for industrial applications. So it's always good to go into the actual hierarchy of the topology, architectural kind of like design of the microprocessor before you say, I want to use this or I want to use that board. Always look at the speed and the buffer time and everything that you have related to the microprocessor being used on the board itself.
Yes. Hopefully soon we'll be using the Adafruit boards.
Oh, سبقتك عينك. We use actually, so part of the designs اللي محكينا عنهم هلا هون is someone came up with a design of using a single commercial ventilator with 4 patients or more. What we had as a fear is that we cannot monitor the flow for each patient with that single ventilator. So what I did was I used the Sensorian sensors, visual proximal sensors, بنحطهم على the breathing circuit تبعيت for each patient. And we hooked them up to actually, if you don't know what it is, an edge board, which is released by Adafruit so that we can monitor the flow. And we collected them via Bluetooth on a platform interface. And we were able to monitor the flow for each patient. So never underestimate.
خلينا نفرجيهم بسرعة شو هي الedge board.
Yeah, absolutely.
I need to.
Edge board, Adafruit, yeah. Edge badge. Oh, there we go. Edge badge, Adafruit edge badge. Because it runs also TensorFlow if you want edge badge so that you don't. Hey, the Spark Fun is also the image. There it is. The one with the Adafruit. It has a small screen. Yep, that's the one. So So this is kind of a badass board, if you don't mind me saying. I love this board because you can do so much with it, and it runs machine learning on it as well. Very fast, like bullet fast. Amazing.
Yeah, I think in our audience today we have
Okay.
computer
So
scientists.
what we did is we interfaced the I2C bus on this board with a sensor known as the Sensirion sensor. It's used on a lot of commercial ventilators, but it's also open to the public to buy. Right now, you might face a bit of problems with the supply because a lot of people were ordering the Sensirion sensor, so it might be out of stock, but you can find it also on DigiKey and Arrow, I think, and I'm not sure. There was also a German website. They have this website, Rieglich. It's also kind of like DigiKey, but for Germany. It's very good. You can find a lot of sensors there that are out of stock everywhere else. Okay, so Narmeen is asking, can we have your design in the Lebanese market soon? We're trying to, because we're still in the testing phase, and unlike other people who have tested it for like 1 2 hours or 3 hours under a lab test, what we're doing is we're stress testing it. So we're testing it for longer durations. We want to make sure that our ventilator can operate for 7 days without actually having any problems. And it's a good thing that we did that, because we're trying to stress our electronics beyond their capacity. We're trying to see what's the worst thing that can happen and how we can manage that. Because every time you push something to the limit and it breaks, you have to include an alarm for it so that it can be raised into the ventilator, and make sure that the operator is aware of it so that they can take the patient onto another ventilator and not compromise their life. How much it can cost? What we're trying to do is to keep it under $3,000. So we estimated that the low-end solution would cost $2,000, the high-end solution would cost $3,000, compared to a commercial ventilator that we have the same properties of, and we're trying to make it also portable so that they can use it كمان بالambulances. And if you want, we can see the design, how it opens up. The cost is 1/10 إذا مش أكتر من cost of a commercial ventilator. So your cheap end ventilator is $12,000. That can give you some sort of perspective of where we're at. Yes, this is the design. Yeah, it looks like a box, but this is the first design. We made sure that our monitor can swivel in its place, and we can displace it so that the operator can see the view however they work. Because when you have a patient on a ventilator بقلب الامبولانس، دايما بيكون في عندك operator قاعد حد الوجه وفي operator على الفيت. So if someone needs to see something, they cannot always have a 360 view. So it's always good to have this monitor adjustable so that they can see better and they can not miss anything. Also, one of the things that we thought about is, let's make it detachable and you can spread it out. Now, the first design was 3 sections, but then we thought with the Lebanon Red Cross, الله يخليهم دايما كمان مستعدين يعملوا الديزاين معنا، سألناهم أنه إذا نحن فتحنا الفنتيليتر شو بدكم تخلوا الفنتيليتر ينفتح على شو؟ لما ما استوعبوا بعدين حطينا 3 designs, and then we had these 3 partitions where we were thinking أنه okay, let's keep the air compressor at the bottom, the battery pack in the middle, and then at the top everything related to the sensors and the breathing system. But what happened in the end was we kept the battery and the air compressor in the lower sector and everything else in the upper sector, and they just open it so that when you take it out, I think, Mustafa, if you want, there's an image of it just spread around on the same page. You can try to scroll through the page and find it. Okay, I think it's out there somewhere. If not on, there we go, there it is. Okay, so basically this is the design. The need for it to open up is basically لما يكون في عنا ventilator الديزاين تبعه جاي stacked ما بيساع بقلب الامبولانس لانه الامبولانس السيلينج تبعه sometimes is low. ف they have to compromise the type of ventilator that they need to put inside the ambulance so that just so it fits. و sometimes بيكون في عنا ventilator without wheels, without casters, so they have to carry it onto the field and then carry it back into the ambulance, which is also كمان detachable wheels where if they're not using it or if it's being stacked again هيدول الwheels بينضبوا لجوا. When they're opening it or trying to move it on the ground, they release and they can move along with the user. So we thought of the design and we came up with a very good solution. They really liked it. So hopefully we can also realize that soon. Okay, could it be used at home in case of a crazy spread of COVID-19? Okay. Ventilators usually need specific people to operate them. Yani not even a registered nurse knows how to use a ventilator without proper training. So no, never. In case of a crazy spread of COVID-19, we will place the patients on the floor and we will act like a بيسموها war medicine, which is basically what we're doing now بالمخيمات تبعول مع المخايل وجميزة مع الموبايل هوسبيتالز اللي ما بعرف اذا حدا يقدر يشوفهم بقلب الفيلد right now. What we do is we basically بدل ما يكون في عنا تخوته بكون في عنا literally مثل sleeping bags وعنا patients عليهم, and we would rather use these and a commercial ventilator with spreaders or whatever, or even repurpose BiPAP machines or paper masks in order for us to inject oxygen into the patients than have these patients being treated at home without proper medical supervision. لأنه ventilators are very iffy, they are very hard to deal with unless you are properly trained for months on end on how to work with a ventilator. It's very, very, very hard to deal with it because you have to keep focused and you need to know how to read each patient and
I think آلاء راحت عندها الكهرباء. صارت لأن أو قبل الميتينج. هلا she will join us. أنا بدي بس خبركم شغلة إنه هيدا الشغل يلي اشتغلوه أنا من شي 3 أشهر تقريبا كنت معهم ب one of the meetings وكنا عم نحكي كنا عم نحكي بالديزاين أكتر. هيدا الشغل من 3 أشهر لهلا اشتغلوه كله. صراحة التيم اللي عم يشتغل عنا more than يعني more than professional بالنسبة للأوتكم اللي عم يطلعوا فيها, وكلهم أغلبهم انجينيرز, منهم يمكن نصهم أو أكتر شوي يمكن فريش جراديويتس, ومعهم سينيور انجينيرز مثل آلاء وغير آلاء عم يشتغلوا بهذا الموضوع. فيس I think صراحة اللي عملوه شيء كتير واو. shall we wait for آلاء ترجع تعمل join؟ بهالوقت خليني لكن خبركم كمان عن جروب كتير مهمة. أي حدا مهتم بهذا الموضوع لازم يتابعها أتليست, اللي هي Open Source COVID-19 Medical Supplies. هيدي جروب انترناشونال مش بس بلبنان, بس Lebanon Response Team كتير أكتف عليها و they are sharing their designs, وعم يعطوا كل شيء عندهم عم بيطلعوه اوبن سورس. اذا بتشوفوها حتلاقوا كتير ناس عم بيجربوا يعملوا اشياء من فيس شيلز, فيس ماسكس, حتى الفنتيليترز. رح تلاقوا انه في فنتيليترز مختلفة موجودة بهيدي الجروب. يس اي ثينك آلاء رجعت عملت جوين. آلاء you need to unmute.
Okay.
It's fine.
Now?
Yes.
All right. Yes, okay. Sorry, it took me some time to log back in. I'm not sure why it took me some time. All right.
Okay. كنت عم خبرهم بس انه هذا الشغل اللي اشتغلتوه اخذ معكم يعني من 3 اشهر. انا كنت معكم بميتينج وكنتوا بعدكم عم
Yes.
تشتغلوا على بالديزاين، وبعدكم عم تفكروا شو بدكم تحطوا بالفنتليتر. فان
Yeah.
3 اشهر يعني اسم الله عليكم، الشغل اللي اشتغلتوه جبار صراحه.
Yeah.
سو
Thank
يعطيكم
you. Thank
العافيه.
you so much.
وكنت عم بحكيهم عن الاوبن سورس جروب، اذا عندك شيء تضيفيه على الجروب الواتساب، عفوا جروب الفيسبوك.
Okay. So on the Facebook group, it's very hard to filter on everything that's been shared. هلا, Tobias and Victoria tried to keep a folder kind of like pinned at the beginning of the Facebook group, but it's always better to have access to the Google folder or the Slack channel so that you can stay updated on all the designs there. لأنه في a lot of designs there, they keep updating them, they keep kind of like improving it, and في also كمان عندكم options of several designs لأنه في medical professionals بيحبوا design A, في منهم بيحبوا design B, so we kept all those together, but all of it is there. If you need any help with accessing it, just drop me a message on Lamba Labs Facebook page or an email on contact@lambalabs.com. I'm always ready to answer when I have time. This is very important to stress right now because these 2 weeks عنا field visits ما طبيعية disaster areas, so it's very hard for me to answer before 8 p.m. So don't question why I'm not answering you on WhatsApp or on the email on time. I apologize, Salaf. كلكم عم تكونوا cute, even doctors and nurses, so don't take it personally.
باي ذا واي لخبركم انه لا هلا بعدها كانت واصله من بيروت، كانوا عم يعملوا مسح للاضرار بشارع مار مخيل والجميزه اي ثينك. فيعطيكم العافيه. يعني عن جد اللي عم تعملوه الدوله ما عم تقدر تسويه.
هلا right now we're trying to cooperate with them لأنه they have the legal entities تحت, so we have to cooperate with the army, we have to cooperate with the municipalities. The great thing is that في areas مثل برج حمود البلديات are amazing. محافظة جبل لبنان awesome to work with. Beirut not so much.
unfortunately لأنه أكثر منطقة لازم يكون
It really depends على the people who are in the positions. يعني مثلا بيكون في عندك sometimes المختار أو حتى ال people in the area which is amazing. بتكون أنت عم تعمل مسح, بيجي حدا من تلاميذ الجامعة بيكون مثلا بيقول لك أنه طيب أنا بعرف المنطقة هيدي منطقتي, بتحبوا ساعدكم أنه امسح معكم وقلكم وين معقول يكون في أضرار أكثر. It's like amazing the kind of feedback you get back out of people لأنه they help you to help others. And this is the real people who are helping on the ground. The people who are willing to help others before themselves. هولي عن جد شابوبا. بكون يعني معانا الدنيا كلها, بس بقول لك انه في حدا اكلها اكثر مني. هيدا الشخص اللي نعتمد عليهم بالفيلد.
الله يعطيكم العافية عن جد.
الله يعافيك.
That's great. طيب to wrap things up, حدا عنده any question? Do we need to open a Q&A session? You can share your questions بالchat إذا بدكم.
Okay, so I'm gonna open the chat so I cannot miss anything. Thank you, Nermeen. It's always it feels good when someone tells you good job because you feel this validation. مرقنا بفترة we had a lot of pushback and it might not be done. فاكرين إنه the ventilator is so easy to make وما بعرف شو. And then you have these people who put all their energy and efforts into making solutions. And then you had people who were crazy like Elon Musk ما بعرف شو عمل بالventilator تبعه. It looks like something out from outer space. Everything from him looks from something from outer space. Yeah, it was an overkill. And then you have other people who tell you we did an open source ventilator, and then when you try to access all the material, you find this is blocked, this is not shared, and none of it has to do with open source. So you look at like, okay, open source ventilator, that's not really open source.
Yes. طيب لكن I think we can wrap things up. Thank you عن جد
Yeah,
آلاء. The
my
amazing
pleasure.
آلاء عن جد. This was an amazing presentation. الانفورميشن اللي اعطيتينا اياها I think الكل عم بقول لك بتشات thank you, that's a great job. و يعني ما عارفين شو بدنا نكفيكم. يعني اللي عم يشتغل على الارض ما حدا بيقدر يكفيه. يعطيكم الف عافيه و thank
بالعكس
you.
انت when you're highlighting these efforts, this is also helping us out. يعني عن جد thank you so much for doing all this great work وعلى الchannel. By the way, as someone who's a Hogwarts fan, every time you use something related to Harry Potter, I like so yeah,
Thank
one
you.
Potterhead to another. Keep it up.
Thank you. Hopefully ان شاء الله more webinars will be on the way. كمان thank you للاودينس اللي شاركونا اليوم بهذا الويبينار. اذا ما راح ابعث لكم كثير فيدباك فورمز. بعرف انتم ما بتحبون وانا ما بحبهم، سو اي حدا عنده اي فيدباك حابب يبعث لنا اياه يبعثها على info@hogwartsoфengineers.com. ما تنسوا تتابعونا على السوشيال ميديا، ما تنسوا تتابعوا لامبا لابس على السوشيال ميديا. ليبانون ريسبونس تيم اهم شيء لتشوفوا. بنزلوا عاده لما بدهم فولنتيرز بالمناطق اللي عم يعملوا مسح ببيروت مينلي. So please تابعوهم وحاولوا قد ما فيكم to share their information. Thank you very much for joining us today. Thank you very much again, Alaa. Hopefully to see you in more webinars in the future. يعطيكم ألف عافية.